Hello students, today we are going to discuss about refraction on the basis of wave theory. So it is very important topic, and in exam the question can be given like this: derive the laws of refraction, derive the laws of refraction of light on the basis of Huygens wave theory. Correct. So first of all, we should know that there are two laws of refraction, and refraction's first law, which is also known as Snell's law, is sin I upon sin R is equal to constant. And what is the second law? Second law is incident ray, normal and refracted ray all lies in the same plane. So we will derive it, but before that I want to tell you a few important points. First, we have to take care of one thing, that ray is always perpendicular to the wavefront. Correct. Second thing is angle I is the angle between incident wavefront and interface. Correct. Interface is a line which is making separation between two mediums, because here we are discussing about refraction, so a line will be there which make difference between two medium. Just above the line, if there is medium 1, so just below the line there will be another medium which is known as medium 2. Medium 1 may be rarer, medium 2 may be denser, and vice versa. Okay. The third point is angle R, which is known as angle of refraction. So angle of refraction is the angle between refracted wavefront and interface. So please keep these points in your mind, so the next thing will be easy to understand. Okay, so look at this. This is the figure drawn here, and I'm just explaining it to you. What is this? This first line is ray. Okay, and this is line, this one line on which I am just making a zigzag line is incident wavefront. So what is this? This is incident wavefront. Always remember that ray is always perpendicular on wavefront. So I already wrote here, this is the angle 90 degree, and this is the angle between wavefront and ray. So this is the ray, incident ray. Here this is the line which is horizontal, and this line is interface. Above this line the medium is rarer, and below this line the medium is denser. Let us consider the speed of light wave in medium 1 is v1, and speed of light wave in medium 2 is v2. As we know that medium 1 is rarer and medium 2 is denser, so we can write that v1 is greater than v2. As we know that light always travels slower in a denser medium. So we can see here, I'm just changing the color. This is the distance which can be written as v1t. This is the distance traveled by a point on the wavefront. For example, I am just locating a green point here. Just a second. This is green point on the wavefront, and as we know that with Huygens theory, each and every point on the wavefront is fresh source for the next wavefront. Okay, so from there to there, the total distance traveled is v1t, correct? So this is one thing. And here, which one point is here on the bottom side of wavefront? From this point, the disturbance goes in the another medium, which is denser in nature as compared to the first one medium. Now the red line is showing here the path of ray, which is number 1 ray. अगर यहाँ पे कोई refraction नहीं होगा तो light will travel in a straight line, but as you can see here refraction is happening, so this is normal. So the light ray will bend towards the normal. So this is the light ray which bends towards the normal. And look at this part, this is the refracted wavefront, correct? So this is angle R, already written here. Angle R is angle between interface and refracted wavefront. So this lower part is refracted wavefront, and upper part, which is highlighted with purple zigzag color, this is incident wavefront. Now we are having two triangles, two right angle triangles. So first we can write here this point is A, and this point is B, and this point is C, and this point is D. So in two right angled triangles, and these two right angled triangles are triangle ACB and triangle ADB, correct? In triangle number 1, if we are applying trigonometry, we can find the value of sine I. So sine I can be written as perpendicular upon hypotenuse. So perpendicular is how much? Perpendicular is v1t upon hypotenuse is how much? AB. And similarly we can find in the lower triangle, which is triangle ADB, the value of sine R. Sine R can be written as perpendicular, which is AD, upon hypotenuse, which is AB. Now what is AD? AD is distance traveled by light, distance traveled by light in denser medium divided by AB, correct? Divided by AB. Now we have to find the value of distance traveled by light. So formula is equal to speed equal to distance upon time. So it can be written as distance is equal to speed multiplied by time. So speed is how much? Speed is v2 in the denser medium. Let us consider the light moves with v2 velocity in denser medium, and the time taken by it to move AD distance is t. So this is the distance traveled by light in denser medium, which can be written as v2t. So the value of sine R, we can write sine R is equal to v2t upon AB. So because we have to find the value of Snell's law, we are going to derive first law of refraction, which is also known as Snell's law. And according to question, now if this is our result number 1 and this is our result number 2, according to question we have to find the ratio of sine I and sine R. So sine I is how much? v1t divided by AB, and sine R is how much? v2t divided by AB. And it can be written like this: v1t divided by AB multiplied by AB divided by v2t. So AB cancelled by this, t cancelled by this, so that implies the value of sine I upon sine R is equal to V1 upon V2. Now what is V1? V1 is the speed of light in medium 1, which is rarer in its nature, and V2 is what? Speed of light in medium 2, which is denser in its nature. As we know that V1 and V2 both are constant, so ratio of two constant will be also equal to constant. So this is the verification of first law of refraction, which is also known as Snell's law. Sine I upon sine R is equal to constant. Correct? Now the next point is, here we have to derive one more law, which is known as Snell's law, second law. Correct? What is Snell's second law? This law says us that the incident ray, normal, and just let me write this part, just a second. Law 2, incident ray, normal, and refracted ray all lies in the same plane. So we have to apply logic on it. So look at this. Logic is incident wavefront first. Ray is perpendicular on incident wavefront. Ray is perpendicular on incident wavefront. Which one ray? Incident ray. Incident ray is perpendicular on incident wavefront. Then second is refracted ray is perpendicular on refracted wavefront. Refracted wavefront. And third part is normal is perpendicular on interface. Correct? We know that, what we know? We know that these three, incident wavefront, number 2 is interface, and refracted wavefront, all are perpendicular to the plane of screen, and these three, incident ray, refracted ray, and normal, these three are perpendicular on these three. इंसिडेंट रे परपेंडिकुलर है इंसिडेंट वेव फ्रंट पे, रिफ्रैक्टेड रे परपेंडिकुलर है रिफ्रैक्टेड वेव फ्रंट पे, नॉर्मल परपेंडिकुलर है इंटरफेस पे. अब सामने जो आपको स्क्रीन दिख रहा है, ये तीनों इंसिडेंट वेव फ्रंट, रिफ्रैक्टेड वेव फ्रंट एंड इंटरफेस, ये तीनों स्क्रीन पे, या हम बोल सकते हैं जो हमें वाइट लाइन वाला पेज दिख रहा है उसके ऊपर परपेंडिकुलर है, और ये तीनों इन तीनों के ऊपर परपेंडिकुलर है. सो we can write incident ray, normal, and refracted ray all lies in the plane of screen, and you people will write in the plane of paper. Correct? So this is the proof of second law of refraction, and which is very important by the point of view of examinations. Thank you.